In the previous videos, we've had a look at quite a few linear equations. Now let us have a look at all those linear equations again and let us see what exactly is common in all of them and what makes them different from one another. Here I have the first linear equation, the second one, the third one, and the fourth one. Clearly we can see that x and y are common in all of them. Also the equal to sign, of course, because they are equations after all. What makes them different are these two numbers in green and in purple. They've been highlighted. So the combination of these two numbers, the one in green and the one in purple, this combination keeps on changing, and this gives me different linear equations. So I can have 2 and 4, 2 and minus 4, minus 2 and 4, minus 10 and minus 50, and by changing this combination I can keep on getting new linear equations. Now let us try and come up with a general form for such equations. Now of course y is common in all of them, equal to is common in all of them, but this number right here in green, that keeps on changing. What I can do is, let us use a variable to denote all these numbers because they keep on changing. So let us say I denote this number right here by a variable, let's say m. So m stands for all these for this number exactly, which keeps on changing and giving me different equations. Apart from that, I have x, which is common, plus I have this number in purple that also keeps on changing. So let us take a variable for this again, and let's say I call this number c. So I can use c to denote this second number, and this way I have a general form for all these linear equations. Now by plugging in the value of c, could be 50, minus 54, minus 4, 4, and the value of m, I can get all these linear equations. Just to put it out there, the name of this kind of form, this form, is called the Slope-Intercept form. Now I know this will be a very confusing name for you right now, and so you don't need to pay much attention to the name. It will be explained later in the coming videos, but yeah, all you need to know is that we have such a general form for all these equations. Now I can have another form for linear equations, which is discussed in the following part. Let us have a look at this problem first. 4 pens and 2 notebooks together cost rupees 20. What is the cost of the notebook and the pen? Now again, the cost of the pen and the notebook is unknown. It may vary, it can be anything, so we need to assign them variables. Let us say the cost of a pen is x. Let me choose a lighter color, let's say yellow. Yeah, so now let us say the cost of a pen is x and the cost of a notebook is y. So 4 pens for x, that is the cost of 4 pens, plus 2y, that is the cost of 2 notebooks, together cost rupees 20. So this plus this costs 20 or equals 20. So that is my linear equation, 4x plus 2y equals 20. Now if you look at this linear equation, this is very different from the form we had discussed in the previous slide, which was y equals mx plus c, right? This does not match with this form. Now here what we can do is, we can shift this, let me get rid of what I had written earlier. Yeah, what I can do is, I can shift this minus 20 to this side and I can get this form, 4x plus 2y minus 20 equals 0. This is a different form of linear equations, and this form is known as the standard form, where a, b, c are numbers. So a here is 4, b is 2, c is minus 20, and this form is known as the standard form, as opposed to the previous form y equals mx plus c, which was called the slope intercept form. Now that name will be explained later. This has a simple name, standard form. Just by definition, this is called as the standard form. So if you can write an equation in this form, and when you write it as in this form, like so, it will be called the standard form. Now can I convert the standard form into the form discussed earlier? Well, of course. I have this equation, yx 4x plus 2y minus 20 equals 0. What I can do is I can shift the 4x to that side. So what I get is 2y. In other words, I am subtracting 4x from both the sides. So minus 4x and minus 4x, right? So 4x minus 4x is 0. So I am left with 2y on this side equals 20 minus 4x. And so I can shift this 2 to that side also by dividing both sides by 2. 2 and 2 cancel. I'm left with y equals 20 upon 2 minus 4x upon 2, and finally I get y equals 10 minus 4x, or y equals minus 4x plus 10. This y equals, sorry, minus 2. I forgot to divide this. 4 divided by 2 is 2. Sorry, this would also be 2. So I get y equals minus 2x plus 10, right? And that, if we compare it with this, y equals mx plus c. Now I have finally written my equation in this form, where m is minus 2 and c is 10.